Zoom is quite weird.
Yes.
Anyway, in this setting, basically, what the problem was, it's, let's take the same code. So it's inside the option. It's inside option data option. It's the definition.
Oh,
so the class none is supposed to implement the interface equals. And the interface was properly resolved, but my error said that basically cannot extend an interface equal. Did you mean implements? But well, I'm using implements. It's not that I'm using extends. It's like I'm touching a place in the compiler where it doesn't make sense to end up there. It's kind of a branch that is lost in the wind, like the way to say. So let's take a look at, I'm lucky enough that I haven't erased my recording in f.replay.io. Let's hope this works. So I was in this state. By the way, I haven't been able to make source maps to work at 100%.
Oh, I don't think they do work on Node.
Okay, then I'm not.
We just have to add that.
Yeah, I'm not the crazy one then. Because Mateusz made everything look way too easy.
Does he have source maps working? Maybe he
No. I'm not saying for source maps in general, for the editor experience. And I haven't realized if he had source maps on or not. He hasn't gave me a complete 100% tour of everything. We had a debugging session where he was using the tool like, oh, I didn't know that existed at this level. Like the very next thing is, I have to try it out. But anyway, I got to the point that I said sometimes I still use the code. So this is like the third iteration of the problem. But I had scoped it down to a place in the compiler, and I had added a console log. Which you've seen only has one hit. So it's a defined problem point to start with, at least. And my console log was finding up the global map. And the global map, in this case, contains all of the global imports that we've seen before. And if you go in the details here, I was checking, like, in between, at some point in time, the call stack. Okay, this is finally ready. And if I, after this line, I was going after, and I had like I have to check the global symbol cache, which is this one. I was resolving a specific location, so I was interested to see what the original location was.
Come on.
And I was trying to resolve the hash. The hash identifier, so give a meaning to the hash identifier. And it seems like I had a positive result, and my map was kind of okay. So I didn't understand why this was weirdly strange, because at a later point I was ending up with an error. I had an error. I mean, I was still debugging the error. So I kind of stitch a breakpoint here and go a few more iterations, and I realized that some branching here is getting weird.
So you went to the place where the error was, and then you went back and began bisecting.
Yeah, I was like jumping, but the place where the error is generated from, and that was an interesting discovery, is generated from something like here. And there is an add lazy diagnostic, which you've seen has been hit one time. I was like, let's check when this is hit compared to when this thing was hit. I was like, the lazy diagnostic was added at a different point in time.
I could see that.
And I was like, okay, let's check what happens a little bit before. So let's point, instead of having the debugger below at the console log, let's have the debugger above. So before the condition, I want to realize what's going on. I had a log. I was pretty sure my cache was filled, and this is filled only once at the beginning of your program. So at the very top of the compiler execution, before the code is even processed.
Yes.
So it's pre-processed and everything runs. So I was fairly certain this was well indexed. This contained the indexes that I needed. If I check a hash in this map, it exists. This was my assumption. I was like, okay, let's branch it over. I was trying from there, and here I had to restart things. I was like, the first time it's hit it, I don't have it just in the start, but let me check the map from here.
Sure.
Maybe I need to clean up some things.
Yeah, I see 2 of those. Yep.
I see two breakpoints hit. Let's go at the very first.
Okay.
That's the very first. And like
the map is 0. That's weird.
And the map is 0. But here I realize, okay, there's a few more hits. There's not only one, which might be related to other stuff, okay?
Huh.
But like, I have a branching that where this is not.
Right.
Sometimes, obviously, this is running on a place where this map is not filled yet.
Yeah.
That was the whole realization which led to actually fixing the bug, which was.
I have a question for you. Do you ever add a print statement? Like, would you ever add a print statement on 66.292?
66.292.
Yeah. Do you see that plus button when you hover? Yeah. Just being able to, exactly. Let's put that in there.
I know.
Like global symbol cache dot size, maybe. We're adding autocomplete. I mean, we have autocomplete there, but it only works if you have one argument. So we're making it better.
No, I think it generally works fine, but I don't have many things where.
Oh, symbols cache, not symbol cache.
Symbols.
This is where I need autocomplete. Okay.
Yeah, this is where Mateusz was absolutely
Look
better.
Look at that. 00048. Boom.
The reason I have not been using this too much is because inside the compiler, this is a very special case where I only have 11 hits.
Yeah.
But generally, you have places like 300,000.
5,000. Yeah.
No, 5,000 would be small. And it's actually one weird thing is that if I use the scoping to reduce the amount of things, there's only a point I cannot.
We're improving that.
Yeah,
you want to be much better with tight loops. Yeah. 3 seconds here does not help you.
No, 3 seconds is like my whole time.
Yeah.
Of execution. I want to go down to like 2 milliseconds.
Yeah.
And that would be 150 calls.
Yeah, sure.
And the other thing is like I can add a condition only when things are scoped down already at a decent level. I would like to add the condition to scope things down.
Yeah. Yeah.
So not having to go back and to the code and add my.
Oh, you can do that now. If you click to edit the expression.
Here?
Not even there. If you click in the print statement to edit it. So we have if we have that panel there, you can always edit that print statement you already added on 66.291. Sorry.
I think my interface crashed now.
Uh-oh.
Yeah, and it got to a completely different part.
Yeah, let's jump back to that panel. There's a little print statements list on the left sidebar that you can click. Yeah, if you click that, that should take you there. And then you can click in that panel to edit it. Cool.
Which panel?
Oh, yeah, if you click the plus button and then you click in that panel, there's a little edit button. I'm not making sense. You know how you click in there to edit it? Yeah. Now in the bottom right, you'll see a little filter button. There we go. There's the if statement. So it is possible to add a condition to go from like 500 hits down to like how many hit it, but we hide it.
Okay. So I was able to access this interface. I don't know how, but when a condition was already small enough.
Yeah, yeah.
If the condition was large, too big, this interface was not accessible.
If it's more than 500 hits, we don't show it.
Yeah, my point is I want to step down like from 100. Yeah, I have 10,000, I want 5.
So what we'll do is we'll make focus mode more granular. So you can focus in on 500 and then you can filter it to like the ones that hit.
Which could be another good solution that would already quite work. Even though sometimes it can be quite problematic if you are if you're still recording, it's fine, but it could be that like I'm hitting this branch of code, but the reason I'm hitting it happened 10 seconds ago.
Yes. Then
if you know it, it's
yeah,
then you're screwed. Yeah.
We will also make
and look, I mean, all of this it's on top of something that's already amazing.
Yeah. But this is why I want to do the call, because I get the feedback and we can make it better. Yeah, tight branches will be fun. Cool. So let's jump ahead a bit to where the solution was, or where you saw the problem.
Yeah.
And then I want to jump into EffectTS
and
talk a little bit about how we can do that DevTools integration.
Yes, I have solved the problem. Okay, now we have to open compiler code. That's also funny to see. Okay, close down everything. We said we had from code this symbol cache.
Yeah. It was 0 until it was like 48 or something.
Lucky for us, it's not mentioned in the whole compiler lingo in more than 5 places, so it's quite specific.
Yeah.
And namely, there is only one place that sets the cache.
Oh, great.
So there is this place which is called try cache ts plus global symbol, which takes an import declaration, so something you import, and does something else which end up fulfilling this cache. Now let's check when this is called. This is called now in the solved code in a place which is called now it's called in this place, which is
loop over every statement in the file, and if it's an import, try to cache it.
Loop over all the source files in your project.
Yeah.
Then it loops over all of the statements in your file and checks if it is an import declaration, then cache.
Makes sense.
Which it's not so unintuitive, but this now it's called at a very specific place.
Yes.
In here as a separated process.
Yes.
And this is called in the normal initialization of the TypeScript compiler.
Yes.
Which is the initialize type checker. This is pure TypeScript.
Okay.
At the very end, we initialize our things. It's like when you create the checker, first TypeScript does its job, and then we do things on top. Now, the order of this before, this statement was in the normal transformer logic that we already have, that loops through the whole statements logic where we collect the fluent definitions and everything else. So we were not doing this as a separated thing. And there was like a race conditioning where something could be accessed before the cache was fulfilled.
Okay.
So like this at the end was the solution, which is pretty easy in terms of complexity of the actual implementation. But to debug was like
usually the implementation is easy. It's the understanding that's hard. And the big thing here was seeing, oh wait, sometimes the cache is 0.
It depends because sometimes like in the issue that Mateusz wanted to solve on the TypeScript compiler, which is a different one.
Yeah.
like it was nice to have a debugger to actually realize where things were happening in understanding, but actually how to do the solution had nothing whatsoever. It's like, yeah, here you have to know how the compiler works, what to call, how a type is mentioned in the others.
That's right. Yeah.
So to some extent, it was very helpful in discovering the actual case to isolate the point where you needed to branch the solution, where you need to implement
a stronger statement would be the understanding is uncorrelated with the actual complexity of the fix. Sometimes the understanding is really hard and the fix is really easy. Sometimes the understanding is really hard and the fix is also really hard.
Which I think was more that type of case, because the implementation was really then awful.
Yeah. I know what you're saying.
If you want a video on that, I can give you a video on that, but that's not that funny. The solution is not a 1 minute thing.
Okay. Let's switch over to Effect. Yeah.
Okay.
So I can talk about 2 different integrations that we already have. 3 actually. And then we could figure out where Effect falls on the spectrum. So React DevTools, we have support for it now. The way, and that means you can pause and look in the React components. You can use the component picker to like select an element, and then it finds the node and you can see all its props and state. The way it works is when we're recording, we basically have a content script for React DevTools, which is in the page. So when React starts, it sees the content script, it registers the hook, and then while React is running, the hook gets called every time there's a React commit, and that sends the React operations into our content script, which we then save into the recording as metadata. So by the time the recording is done, we have metadata for all the operations. And what's really nice about that is at any point when you're looking at the replay, so you go to like minute 2, we can fetch the operations and then play all the operations that have happened up to that point. And we have enough to show the component tree. What we can't do is get all of the props and the state and the hooks for a given component at that point, because that's not in the operations. The operations just tell you like what's added and removed from the tree. So to get that data, we do a console eval, which is exactly what React DevTools, the front end, does anyways. It just does a console eval, gets the data back, and then it can show it in the UI. So from a mental model, our React DevTools works exactly the same way in replay as it would without replay. Without replay, the operations are being sent into the hook and then sent on to the front end and then shown.
It's almost like you have some hooks that gives you access to some specific information, but then it's like you could implement it for replay or for anything else that needs that type of information.
Yeah, another one which we're going to do soon, Redux DevTools, will probably work the same way. So, Mark Erickson, the maintainer of Redux, is on the team. He's going to start Redux DevTools in a couple weeks. And we could do the same thing where while we're recording, we have the same hook. It's giving the updates to the hook, and then we're saving that as metadata in the recording. Another example of this is the network monitor, which is not like a framework. It's a first-class DevTools. But as we're recording, we see that there's a network call, so there's some network activity, and we just record that point in time. So the recording has some metadata about all the points in time where there's network activity. And then when we're replaying, we play to each point. We get all the network activity. So we get like the headers, the response body, the request body. And then we could show that in the network monitor synchronously. The nice thing is the recording itself doesn't have to have all that data. It just needs to know about the points in time to play to and get the data later.
Because then you can always generate the data back.
Yeah, exactly. The last example of this is Jest. So we have decent support for Jest now. I mean, we can record a test, but what we really want to do is show in the console or in its own like Jest panel, the test spec and all the assertions that were failed, that did not work.
That did not work.
You know, like, that was bad, that was bad, that was bad. So we do that, I believe, with an analysis. So we have like two types of analysis. One is give me a line of code and an expression to run, and I'm going to go do it. The other is a little bit more intense. I believe we say there, run this expression on every frame enter, and then check something about that frame and maybe send the data back. And I think that's what we're doing here to see what's going on.
Okay, so let's think for effect for a second. What data do I have in general? It's like there is a fiber runtime where effectively every operation of your program ends up running into. When you create an effect, that is just, I can show the actual code.
Yeah.
It would be helpful in very simple. Lucky for me, I have Peapod, otherwise this would take a decade. No, that's not it. I have a few projects.
That's nice.
Yeah, this is nice. Core. Might have been better for me to get it from this, which is a huge refactoring which is going on, but the code is way more clean. Gitpod pre-built on a specific PR.
Yeah.
Let's take a piece of code in effect, and it's like am I not using the proper TypeScript version? Probably. Yes, I'm not using the proper one. Okay, it is running. Let's see this effect.succeed. So when you do something like effect.succeed, you end up creating a class. Okay. Fundamentally. And when you do a thing like, let's do a simpler one, which could be a flat map.
Yeah.
Flat map again ends up simply being a class which reference your functions. Sure. So when you build up an effect, nothing executes. Your code is not executed in any way. When does the code actually execute? When I do an unsafe run operation. And sure. when I do an unsafe run operation, in this case, I want to run it to a promise. I call a few internal functions. I have to get one which is okay. Unsafe run with I believe is the innermost one. Yeah. I create a new fiber ID, and you see that when a new fiber ID is created, there is an optional trace element.
Yeah.
This trace element is embedded. If you see here, for example, I have this.
Do you always have fiber IDs?
I always have fiber IDs. Not always I have traces. If
I don't need trace. I need fiber ID. If I have fiber ID, I think I'm good.
Well, no, because you can't know from a fiber ID where it was originated from.
Well, you can't, but I might.
You might. But it might be very, very hard for you to know that.
Okay. Keep going.
And I also do code transformations. So the actual stack frame that you parse, it's not relevant to my piece of code.
No, I wouldn't look at the call stack. Keep going.
You don't have my source code. So
okay.
Anyway, regardless of the fact, let's check inside this unsafe run promise, unsafe run cancelable, unsafe run with, blah blah. Yeah. I create a fiber ID. Then I have a set of children fibers.
Yeah.
I maintain the whole hierarchy of fibers around. I create a fiber context. Yeah. I run some things to add. This is all crazy low-level stuff that comes from Zio, but inside my fiber, there is a run until.
This is so nice.
Something maybe. Let me close down. This would be better. This is fairly large code. Might realize this does a few things. Run until. Run until runs for a specific number of operations. A fiber is only allowed to do a number of operations before it yields back control. So yeah. you can never stack the process by running too many things on the same one. Yeah. Like run 1,000, then it yields back control to the runtime, other can work, and they come back.
Yeah. So we'll have to pick this up again and do a second call. But here's what I'm thinking right now. In the simple world where I have a function that's being called because it's being called by effect, there's likely to be a frame or many frames on the call stack that reference the fiber. Is that right?
There's like the only frames you have.
Exactly. That's what I'm thinking. Yeah. Because
the operation is even lazyfied.
Yeah.
So any relationship to prior time is lost.
Yeah. So one of the primitives we have in replay is if I have a function reference, replay knows the location that code was defined, which is good.
Yeah, that's basic reflection, for example.
Yeah, but you don't have that in user land. You have it in DevTools land.
But you might add in DevTools land that functionality like inside here, because this is a place that will run every operation, like
that's succeed, what I'm thinking.
Flat map, stuff like that. So if you inject inside here, you have the full overview.
That's exactly what I'm thinking. I can know when I'm paused, that I'm paused in a fiber because I look at the call stack and I see the fiber. I can then look at the fiber and I can see all of the functions that would be called, maybe the current operation.
Here you have the current operation, the full continuation stack. So where the program is supposed to end up doing.
I can also do an analysis to see all the times that fiber was doing some operation.
For every fiber in this place, there is.
But that's my point. The fiber ID is critical because I would see every fiber's operation, but what I want to do is filter that to just see the operations for that given fiber.
Yes.
I could do that too.
And here, not only you have that, you have the full relationship trees between fibers, who forked who is joining on who's waiting.
So Michael, what's hard about this? This feels easy.
It's not that it feels hard. It feels definitely a very good possibility. And not only that, in fibers, the operation may have actual traces which points to userland code. Userland code is different from the whole stack because from the purpose of a user, if this operation fails, what do you want to see? You want to see this call and you want to see this call. You don't want to see what's inside this mess. So what ends up doing is in here, the compiler automatically fills up this argument.
Yeah.
And the compiler automatically fills up, for example, here we have a composed operation.
Yeah.
Anything here will end up having this trace. So it's like I'm doing this job inside the fiber for the user at this position.
I don't think we would want to use the trace. I think we would want to use the actual functions.
It depends.
Does it? What would you want to show in DevTools?
Here, what ends up compiled.
Yeah.
This is not a one. This ends up being compiled as this.
Yeah. Okay.
You have a different shape in user code. What you would want to see is both.
Okay, so let's talk about the dumb version. In the dumb version, we say, okay, we're going to show you what was generated. We're going to give you userland generated code. And in the smart version, we want to go back to the original code, which might have to use the trace.
But something like, seriously, if you check the various insanities, this fiber ID could be made by another fiber.
Sure.
So if for you that the call stack that generates these has nothing to do with the user operation that led to this generation.
Yeah.
So that information is not propagated in the call stack at any point unless you actually watch these traces file. So I'm not 100% sure you can get to a point where it makes 100%. But in a dumbed down version, even seeing this information as it is in compiled code, it's fine.
Yeah, I feel pretty confident about showing a compiled code version. But then as soon as you do that, you say, well, shit, what I really want to do is show the original version with some more trace information. Yeah.
Well, or rather, would be very important to show me both views of the thing. Like, this happened for this user operation with this trace, but the actual call stack that got executed was that. Because this for debugging is really nice. When I have a problem, okay, I can filter by the userland code that generated the problem, and okay, let me see the actual call stacks of things.
Absolutely. Okay. So maybe the next step here would be to sit down with Brian when he's around and looking at component stacks and begin spiking out a version. Because I think from what I can see here, we could do a simple proof of concept very quickly.
And if you need, I can add, I have full control of what's going on here. I can add conditionally. Yeah. Like if you provide me a global condition that I can access, I can conditionally call hooks and do things for having this works out of the box. I would be totally open to.
Absolutely. Okay. This is going to be really fun to show. This would be really fun. Look, I think you get this, but observable.js, RxJS, they all were very difficult to debug because you don't have the call stack anymore. And if we can show an example of how you can use these higher level patterns and the debugging is easier, like you flip it from like it's too hard to it's so much easier.
Now this
then
is only
a lot more people would.
If you need to trace like something that's happening on an array, you would still have normal level things.
Exactly.
So
yeah, this is cool. Okay, let's see what we can do in a month. It was really great meeting you.
Really great.
Yeah.
Pleasure.
All right.
Thanks, everyone. Looking forward to the recording too. So
yeah, I'll send you the recording over as soon as I have it.
Awesome.
Usually Zoom takes I changed the config to have actual quality of the recording, so it might take an hour, but I'll send you over.
Do you mind
Excellent.
if we would publish the recording as well on the Effect YouTube channel? I think this might be interesting for some as well.
Yeah, let's go for it.
Yeah, that sounds great.
And the only reason I'm cutting it off now is I actually have a hard cutoff, so
No
I gotta run
worries.
to another call. But
Ping me anytime you want.
lovely.
We are in contact in Discord and anything else.
Oh, I will. Absolutely. Bye-bye.
All right.
Bye, everyone. Cheers.
Nice to meet you, Cecilia.
Nice to meet you.